Thanks for coming. I'm going to be talking about what we have in the standard library of Ruby. And what I found as I was learning Ruby is that there was a lot there that I didn't know about. And I was doing Ruby professionally for a while before I even discovered some of these things. So when I pitched this proposal for RubyConf, I said that I was going to be talking about this stuff for beginners to intermediates. So I'm curious how many people here consider themselves beginner, intermediate Ruby developers? A decent number, and some liars. But also what I found is there are a lot of experienced developers who don't know about these libraries as well, and some of the tricks that are inside them. So what I'm going to be doing is walking through, talking about what the libraries do, talking about the concepts inside them, showing some of the tricks of the code that they do, and hopefully what I want you to be able to do is look at them, learn from them, try them out, try building some things on your own and not just going to look through Ruby gems for solving some problem that you might have. So I encourage you to, if you like, open up your laptops and clone Ruby or just look at it on GitHub and walk through some of the stuff with me. So I'm Jim Gay. I'm Saturn Flyer on Twitter, on Bitbucket, and GitHub, and Gitorious, which you should check out as well. So one of the things that, as I was learning programming in general, I would hear about the standard library of Ruby versus the standard library of another programming language. And I think there's two concepts here that, there's the standard things that are in array, for example. And that's your standard library, or hash, and all the stuff that you can do with those things. But then there's also the extras that come along with it. And what I'm going to be talking about is the extras, right? At a certain point, I realized I needed to get to know Ruby better, and so I decided to look at the code. And not knowing C, I saw this, and my eyes! What is that? I look at that, and I had no idea what it was. And this is actually the marshalling code. So I would put it aside and decide, well, I have to learn some C before I can really get to know Ruby. Or you could buy Pat Shaughnessy's Ruby Under a Microscope, which is a fantastic resource for learning how all this stuff works. But what I was shocked to find was this. I was learning about gems and how to properly build gems, and you have your Rails apps, and they have this lib directory. And I looked in the Ruby source, and I saw this lib folder there, and I couldn't believe it. Like, wow, there's a lib folder. And I opened it up, and it was just plain old Ruby code. There was no C in sight. So I want to encourage everyone here to just go and look through there. There's all kinds of fascinating things in there, useful things that you don't have to go out to Ruby gems and rely on Bundler to pull it in and figure out dependencies and all that. It might just be the tool that you need might be right there. So the first library I want to talk about is Delegate. And if you're using Rubinius, you have to install, what is the name of the gem? Ruby SL. That has a standard library, and it's all gems, right? If you have MRI, it's just right there in the lib directory. So this is all you have to do to get this library available. You don't have to add it to your gem file and do bundle install and all that stuff. It's right there. So when I think about how code works, I try to visualize it. So I'm going to walk you through that a little bit, then we'll get into some code. I forgot to start my timer. We'll get an extra few minutes. So let's say we have this user object, right? It has some information on it, and we can send a message to it. Tell me, user, when were you born? And I get back this date object, right? But in my program, maybe I don't really want all of that stuff. I just want to display the year. I ask you when you're born, and you say, oh, this is it. And I don't necessarily want to go and change that born method that handles the message that I sent to it. I'm only using this in a particular place, maybe in a presenter or some sort of display area. So this is what you can do with the delegate library. You can wrap it in this decorator, and it's the decorator's responsibility to handle this message. So you send the same message, and this object is acting as if it is the user, right? You're just kind of pretending, for now, you just be the user, but you'll have some extra behavior. And so internally, what it does is it says, user, when were you born? I'm going to translate that and give me the year, and that's actually what we want to say, right? So the delegate library gives you these three things: delegator, SimpleDelegator, and delegate class. I'll walk through them. And I thought it'd be interesting to try to implement this stuff, the bare bones of these libraries, in something that would fit into a tweet. So this is the smallest implementation I could do for the delegator library. So if you want to tweak that real quick, that's enough time. So I'll expand it for you. This is what it's doing. Let's say we called it delegator. You initialize with an object, and you store a reference to it. And then you use method missing. Any messages that it doesn't understand, it will send to that object. So if you're not familiar with method missing, it is so awesome when you learn it, and then you start using it and realize what a mess you've made. But it's still good to know, and this is how the delegate library works. When you send a message to this delegator, if you initialize this delegator class, you send a message to it. If it doesn't have a method defined that responds, it will say, OK, none of my ancestors have a method with born or whatever it is. So I'm just going to go to this method missing hook. And so you can define how you want to handle this. And what this does is it says, all right, I've got a reference to a separate object, and I'm expecting that object to know what to do with this. So I'm just going to take the name of the method that came in, any arguments in the block, and just pass it along that way. Whatever happens, happens. So that's my simple, dumb implementation of this, right? So let's just take a look at the user that we initialize. This is actually in the documentation. I changed it a little bit, but if you go and look at the delegate library, this is the sample that's in there. So I want to know when the user was born. And I could add another method to the class and say, well, give me your birth year. But I don't want to pollute my representation of a user of what it is with extra stuff just for a particular case. So what I can do is that instead I can make this user decorator. So I can use this delegator class that we created before and say, all right, I'm going to initialize, and I'm going to have a reference to that user. And when I call born, it's just going to call super, which will go all the way through, hit method missing, ask the user for born, and then call year on that, right? So what we end up with this, same exact thing, decorated user born is the same as user born year. And this allows you to have this decorated user take the place of the user. You can just give it a little extra behavior for this particular case and just swap it in there. So the problem is that in the implementation that we have, decorated user is not the same as the user. They're different objects. But we want this decorated user to just sit in place and act like it is the user that we care about. So we can do this. We can just define this double equals method, right? So just say, anytime I compare you to another object, if that other object is the same as the one that we've stored a reference to, then return true, otherwise it'll be false. The problem is, what if we're looping through and we're comparing something we've already got wrapped? What will this be? False, right? All right, so that's fine. We can fix that. Not something I would have thought of originally. I probably would have written some code, started using it, ran into the problem, and then realized, oh, I've already wrapped this thing. So we can just return true if the other object that we're passing in is me. Like if it's the same object, just return true. And then it works. But this is already solved. All you have to do is require delegate and inherit from SimpleDelegator. And there's a whole lot of methods in there, I'll show in a bit, that are already defined like this. The problem has already been solved for you. So you don't have to bump into those errors, find out where the pain points are. You can just use SimpleDelegator. So here's the structure with a lot taken out. But SimpleDelegator inherits from this delegator class. And even though this is the same name that I used earlier, this is the one that we're going to be looking at that is defined inside the delegate library, right? It inherits from basic object. It has this initialize method, which you can see, all it does is it calls setObj and passes in this object. That's defined down here. And you can see from this, it raises an error, right? So this is designed for you to inherit from, and you define your own methods. Likewise, method missing, just get the object and send it. The same thing we did where we had an object reference, but this just has a method. But this also raises an error. So you wouldn't ever initialize a delegator object. You would make your own class, inherit from it, and then you have to define that method. So that's exactly what SimpleDelegator does. It stores this delegate SDObj method. But one other thing that it does that is very helpful is when you're setting the object, so when you're initializing, it makes sure that you're not trying to initialize with yourself, right? Or set it to yourself. Because you can call this method at any point. If you're wrapping an object and you want to swap it out to another object, you don't want to accidentally swap in something that's already been wrapped. So if we were to do our own implementation of this, our user decorator, where we just inherit from delegator, you might make the mistake of doing this. Say, well, I just need to set it to something and then get it. But the problem is, this is what you'll run into. So there's a lot to learn from just reading the code and seeing how this problem has been solved for you, not going down the road of trying to implement your own. Just say, I know enough method missing. I'm just going to use that in a class that I create. Over here, the problem's solved. So I've done this. I've made my own decorators or presenters. And the one thing that I don't like is these method names. They're really ugly. It's great that there's a standard interface across all of them. So you can use polymorphism in your application and swap different decorators in and out. And if you're going to call a message, call getObj or setObj, it's always the same. But when I'm writing my code inside my methods, I want it to look like this. Right? I want it to map to the domain that I'm using. If I'm working with the user, I just want user or user equals or profile equals. So one way of doing that is creating your own decorator class, inheriting from that, and then just aliasing these methods. That gets kind of cumbersome. It's repeating code over and over again. And when I know that I'm doing this in my application, anybody on my team is doing this, we see this type of thing, and there's a pattern happening here. So let's try to take this out. We know this is how this works, and let's just let the computer do the work for us, right? That's what it's good for. So you can learn about how Ruby class inheritance works just by reading this library as well. There's an inherited hook that when you inherit from a class, you can do things with the class that's becoming the subclass. So you have this self.inherited method that we're defining on our decorator class. And it has a reference to class. And what we can do here, what I'm doing is I'm saying, split up the name. So if there's any name spacing, I want to get rid of that. My app, user decorator. And I want to take user decorator off, so all I have is user. And then what this code does, not necessarily that you know exactly everything, but what it's doing is just saying, if you've got user, just downcase it. Or if you have shopping cart, just downcase it and underscore it. If you have active support in your app, if this is a Rails application, it's really easy to just send those messages to the string. This is how you do it if you didn't have active support. And then this is exactly what we did before. So we have the class in hand, and we can call alias method, object name, getObj. So this is where user shows up and user equals, right? So I like doing that because then I end up with this stuff. And I still have those getObj, setObj methods. So the polymorphism argument still applies. But when I'm writing my code, I want to use a word that refers exactly to the concept that I'm writing about. So let's take a look at the delegator class. It inherits from basic object. And then it does all this weird stuff. Remember the first time I read this, I saw this, and there were these magical methods up there, and I wasn't really sure what it was. It's duping kernel, evaluating it undefining it, and then including that duped module. Really strange. The reason for this is we want our SimpleDelegator objects, which inherit from this, to act sort of like objects, sort of like basic objects. If you're not familiar, basic object has some very few methods, fewer than object does. And the difference here is that objects have this kernel module included in them, and they also inherit from basic objects. So what we're saying here is Delegator class is saying, I want you to be like an object, but I don't want these methods. So all of these are being pulled off. You're saying undefine these from this module that I have duped, and then include it. And the reason for that is we want toS and inspect and all these other things to hit method missing. So it goes to our wrapped object. So that's what's happening here. The whole reason this exists is so that we can pass these through to the object that we've got internally. Which is great because when you call user inspect, you get this, and user toS, you get that. And likewise, you get the same thing from your decorated user. So it really does look and feel like the object that you want. It's just got some extra behavior. The weird thing about it, though, is you run into this case where it doesn't delegate, or it doesn't undefine these and send them on. You still know that you have a user or you have a user decorator. This can become troublesome for you if you use something like that, maybe in a Rails application. Because if you ever build your own and you find that you're using this form_for method, which looks at the name of the class and then tries to figure out where it's supposed to go, you have this odd action, user decorators /1, which is probably fine if you're building an app for costume makers or something like that. But we really just want it to go to users. DisplayCase is a gem that helps solve this problem. This came from Avdi Grimm's Objects on Rails. And what he does here is he uses alias method. And what this does internally in Ruby is it actually copies this method. So you're saying, give me a method that's under class, and define it exactly the same way as class is defined. So you have two methods that do exactly the same thing, same procedures. Whatever is defined in one is now in the other. And then it gives them the opportunity to then go and redefine class and say, don't give me your class, give me the wrapped objects class. Draper is a little different. Draper is not SimpleDelegator. I think they have method missing inside there, and there's a lot more code done to figure that out. And they actually tie into active model here by delegating model name to the object class, and they get their object class from the inferred object. So there's a lot going on inside of Draper, right? And that's all to solve problems like turning user decorators into users. So understanding this concept will help you in developing simple little apps where you try to just do some method missing magic to just wrap an object, and you run into this type of thing. That's how those gems do it. So if you're going to build your own, you need to know about that thing. Are you going to redefine class, or are you going to try to figure out what active model is looking for and hook into it similar to the way that Draper did? So the other thing that blew my mind when I was reading the delegate library was this thing. You can see it's defining a method, and it's a capital letter. Who makes, like, aren't constants capitals? Isn't that one of the rules of Ruby? Like, everything starts with a capital as a constant? Apparently not. This comes with it, and in fact, in the documentation for it, it says this is the main interface for this library. I rarely see this. I always see people use SimpleDelegator. I always use SimpleDelegator. But according to the documentation, this is what you should be using. So the way this works is kind of like this. That's really how I see it. But it's just making a new class. And if you have never done this before, you can call new on class and pass in some other existing class. And that returns a class that then you can go in effect. and allows you to dynamically create classes. So if you want to do something like this on the fly, you can do that. And I like the fact that it's capitalized because it makes me think about the fact that I'm creating constants. And then it returns the class at the bottom. So this is what our structure is. And I want to talk about how the ancestry is built. The ancestors are all the classes and modules. When you hit method missing, it's going to go and look through all of these things to find a matching method, and then go into your, when you send a message to an object, it'll do that. Then it'll go to your method missing hook. This module is that kernel dupe. It has no name. It was dynamically defined. It wasn't given a constant name. And so this can be kind of tricky when you're dynamically creating constants. If you don't give them names, you can run into ancestry like this, and you might actually look for the name of a class or call name on that class or module, and it will blow up because it doesn't actually have one. But this is what you could do. Going back to our other example, we could make a user decorator that just uses delegate class, and I pass in user. So I'm saying this is how I'm making an object that's going to act on behalf of a user. But you can see what happens to the ancestry here. We have this dynamically defined class, and we lose reference for what it actually is. But I want to do all the awesome metaprogramming stuff that I did to alias the methods so I can use them. So I can actually just assign a constant there, call class new, pass in delegate class and an instance of a user, and get its class. Do all the same stuff that I was doing before. This was all to alias the methods for user, user equal. So that would allow me, if I wanted to create something on the fly, I didn't know what kind of classes, or I wanted to be able to add classes to my application and have presenters defined for me automatically, I could do this. And I just get the class from my object and pass it along. And then, of course, I thought it would be awesome to make a really cool gem to do it. That doesn't exist, but decoratificationizer. So you could do this. If you wanted to just pass in an object rather than a class, you could pass in an object, do exactly the same thing. Use delegate class to define your class, and you've got a reference to it here. You can assign that to a constant and do whatever you need with it. All right, forwardable. I'll talk a bit about how these two are different a little later, but this is the way I see forwardable working, right? I've got a user, and the user has an address. An address didn't fit in the little hexagon I had, so I shortened it up. So if I send a message address to user, I expect to get this address object. And then I could send city to address and get Miami, right? But maybe in my application, what I really want to do is just ask the user either what city are they in or what's their home city, and I just want it to return to me Miami. I don't want to spread knowledge throughout the system that the user has an address, that whether it's current or it's their home address or whatever it is. I just want to know that there's an address associated with this user, and I want to know the city that they're currently in. So this is how I see it happening. This address, this isn't a wrapper, but it's more like an internal reference to an object. And I don't care from the outside. I just want to say, give me your city. And internally, it will say, I'm going to pass city along to address and then return that. Just forwarding it. So this is the forwardable library. It gives us forwardable and single forwardable. And then there's forwardable method or module that fits in the tweet. So you can tweet that. That's actually pretty faithful to what forwardable does. But I'll expand it a bit, and we can take a look at it. So the difference, of course, with this is it's a module. So you could create your own class hierarchy, not have to inherit from this. You just kind of add it wherever you need it. And what it does is it would define a method on a class. You extend a class with forward. Define this method, and you can say, this is the reference that I want it to go to. So in this case, it might be address, right? And then here's a method name. And one of the really cool tricks that I found in reading this library was I can give it 3 arguments, and that third argument, if I don't give it one, if I only give it 2, it's just going to say, well, your third argument is your second argument. So it actually evaluates that, and I can reference the third one. If I only give it 2, it's just going to use the same exact name. So it just assigns it if you didn't give it a third one. That's really useful. And then what it does is it evaluates the code below in the context of the current class. So if you've extended the user class and you're going to forward to address, it'll say, all right, I'm going to define a method here, whatever alternative is. So if it's city, if I pass in city, it's going to define that, whatever args there are, and then it's going to take my reference, my address, and say, send it city, and pass along everything that comes with it. So let's say we have this address, right, and a person. The person has a name and an address. This is just some structure to get you to understand how this might work. Like maybe you have this in a database, but this is good enough. So I've set home to be Main Street, Miami, Florida, whatever it is. And then I assign home as the address for the user. So in my application, if I want to ask it what city, I could say, well, get the user's address and then ask that address for its city, right? But that means I'm going to be working with multiple objects. And if you do that, then the responsibilities of your code kind of seep into the relationships that exist in your objects. And you should try to avoid that. Because if I only rely on the user to know about where it is, then I can just ask the user or tell the user to do something. So this is essentially what was happening with forward. If I extend it, I can do this. I can just say forward city to address. It's the same exact thing. It dynamically defines that method. So at load time, when I boot the application up, it's going to go through this class, define those methods. So this is different from method missing. It doesn't go through looking through the ancestry to find a method. It's right here on this class, so it's going to be much faster. And then I can just have the user tell me what city is it, and we'll say Miami, right? Now the other thing that I can do is here's the alternative. Before, when I didn't give it an alternative, it just said, all right, I'm going to assign it to the one that you gave me in the second argument. But here I can say, I want this to be home city. So this will be where you live, or whatever the concept of home city is in the application. But what happens here is if I call city on it, now it's a no method error. It doesn't define that. It only took the third argument. But it allows me to do this. I can very easily have this understanding of a relationship where a person has an address, and I can just say, anytime these methods are called on the end, just send these other methods to that object. But here's how it works in Forwardable. When I first saw this, I thought this was really weird syntax and un-Ruby-like, this def delegator thing. But it's essentially the same thing that we had in our forward module. It takes 3 arguments. First one is the object. The second one is the message that you're going to pass to that object. And the third one is the message that you're going to receive to send along. So I want to talk a bit about how you can clean this up. If I'm not going to do the home city thing and I just want to pass along city, number, postal code, you can do the plural version, right? Def delegators, the first one is the object you're going to send it to, and then any number of method names afterward. And then this really weird syntax that I was surprised worked. I don't know why. But you can use pretty much anything as a key in a hash. And so this is just a hash argument where I can say I'm going to delegate all of these things to that. And I prefer to write it this way, and I prefer to read it this way, because this is how I think about it. Any of these arguments are just going to go over to that thing, right? But when it defines the method, it evaluates it in a string, and it will turn this into a string, so you can actually use instance variables. So you don't actually have to have a method. You can have an internal reference to another object. It can be whatever you want, and you just put that reference there, and that'll work as well. So when it defines the method, it'll look for that instance variable. ActiveSupport from Rails has its own way of doing this, which is nice in that it has this allow nil flag, which Forwardable doesn't have. But what happens is if address is nil, you can just say, give me the postal code, and if address is nil, just say nil. It won't throw an error. It won't say there's some problem where you called nil on, or you called a method on a nil class. But the other thing it does is it allows you to say prefix true, and it will automatically figure out what that is and define the method as address city. So that helps you create the interface that you want for this person class without revealing that there actually is an address object, and that object has other things. So you can build a library for something and adhere to this interface that you design and change the implementation later. The other thing you can do is define your own prefix. So ActiveSupport has this, Forwardable doesn't, but there's really nothing preventing you from writing your own methods that do this. All you have to do is say, well, I'm going to pass in an options hash, and I can do my own allow nil or allow blank or prefix, whatever you want to do, and you can do the same exact stuff with the same code that's in Forwardable. You can create your own. I haven't used this much, but single forwardable is actually really nice. I only discovered it recently. So I don't know if any of you have code like this. Something goes wrong. You capture the error. You send it off to some external system to keep track of it. I've found a good thing to do in my code is to not reference that third party directly. I want to build a facade between me and it because maybe they'll go out of business. Maybe we'll decide that we need features from some other library. For example, let's say I want to move to AppSignal. I want better ties in with ActiveSupport notifications or something like that. So I can start with my delegator sending stuff, this notify method to Airbrake, right? But this is the contract that I want to have. I want to say save for later. I'm going to look at this later. And so this is what I would use in my application. I'm going to say, this is how I'm going to handle it. I don't want to reference this third party directly. And then later I can change it, say, well, they use notify, and they use send exception. That's OK. I can still use save for later. So I've designed my app so that I can swap out the third party. So the difference between these is that at runtime, you can wrap an object in SimpleDelegator. You can add behavior to it. You can have this object, your wrapper, act like it is the other object that you care about. And Forwardable happens at boot time because it's dynamically defining methods. So you're not going to be changing things there. So I look at this in terms of Forwardable is great for when I know the relationships ahead of time, when I know what methods I need to forward ahead of time. SimpleDelegator is great when I either don't care what methods are going to come in because I'm just swapping in another object and I want method missing to pass it along, or I don't know. So it allows me to build, for example, an interface where if we're going to expose new information to the user, I can just swap this in, and if there's nothing defined to override behavior, it will just pass it along. So there's a lot of similar projects out there that I encourage you to go check out. You can write your own stuff. You can use these libraries. You can explore them and figure out the concepts and the way they use them. I wrote one called casting. Nathan wrote one called rep that uses a lot of Forwardable and doesn't use SimpleDelegator stuff. Here are other examples of SimpleDelegator style approaches. Definitely check those out. I send out tips on a weekly basis from my newsletter. You can sign up there, and I'm selling a book called Clean Ruby, which talks about a lot of this stuff and how it applies to your application architecture. You can get 20% off on the book. All right, thank you very much for coming.